Okay, I'm going to carry on with May 2017. These are the exam questions, and I'm going to start through. I've got one A, B, and C already up on the Canvas page. We did that on one of the Friday afternoons. I think I did D and E on the very last Friday, but I'm going to start again with those, because I'm not sure, I can't actually access the Panopto with my equipment at home. So I'm going to do it this way, and then, you might get it twice. So D, find the equation of the plane tangent to the surface Z equals x squared minus 2y squared plus 3 at the point 1, 1, 2. What is the normal at 1, 1, 2? Okay, so the way that these work are, right, the plane, what we say is Z minus the Z coordinate, and there's the X, and there's the Y, and there's the Z. Z, and then it's dz by dx evaluated at the X coordinate, which in our case is 1, and we do it as X minus that value 1, plus dz by dy evaluated at Y equals 1, and it's Y minus 1. Okay, so we've got Z minus 2, right, so here we need dz by dx, dz by dx, which is 2x, so dz by dx evaluated at x is 1, so it's 2 times 1, which is 2, so it's 2x minus 1. And then we need dz by dy, that's going to be minus 4y. dz by dy evaluated at y is 1, it's minus 4. So that should be, oops, forwards, I need to put that out. So it's minus 4 there, y minus 1. So we can simplify this, it's z is equals to 2x minus 2. Minus 4y plus 4 plus 2. So z is 2x minus 4y. The minus 2 and plus 2 cancel out, so it's plus 4. So that's the equation of the plane. And normal, to get the normal, what we need to do is we can say this is the same as 2x minus 4y minus z is minus 4. So basically I've taken that over there and taken that over there. Okay, and then the normal is 2 minus 4 minus 1. The normal is the coefficients of the x, the y and z. Well, I'll just call it in the z when I didn't need to. It's the coefficient of z, which is 1, or is minus 1 in fact. Okay, so you've got to include these signs as well. Minus 4, minus 1. Right, E. What's the question say? Y equals 2x plus 1 to the power x. Find dy by dx. So to do this, we start by taking log of each side. Log of each side. So we can say ln y is x ln 2x plus 1. Then we differentiate both sides. Ln differentiates to 1 over y, ln y, but we're differentiating with respect to x. Differentiate with respect to x. dy by dx. Now this is a product rule, so it's first times the derivative of the second. Okay, first is x, the derivative of the second, so it's ln, so it's 1 over the 2x plus 1, and then times 2. And then it's plus the second, which is ln 2x plus 1, times the derivative of the first, which is 1. So we can say dy by dx is y times 2x over 2x plus 1 plus ln 2x plus 1. And we can also say dy by dx. Y is actually 2x plus 1 to the power x. 2x plus 1 plus ln 2x plus 1. Okay, and that's your answer. Right, the next one. We've got 2 more questions. This one here, I'll do up here. The integral from 0 to 5 of 1 over x plus 8. Well, the integral of 1 over x plus 8 is ln of x plus 8 between 5 and 0. So it's ln 5 plus 8 minus ln, let's write that A1 there, ln 0 plus 8. So it's ln 13 minus ln 8, which is ln 13 over 8. A2. Right, for this one, you've got to observe that the top is half of the derivative of the bottom. And we're going to use the rule. If you've got the integral of f dash of x, over f of x dx, it's ln of f of x. But with our particular example here, the derivative, if the f is x to the power 4 plus 3, the derivative of x to the 4 plus 3 is 4x cubed. And we've only got 2x cubed there. So we've actually got a half. So this we can have just, if you've got a multiple there, in our case this one's going to be a half because the 4, which is going to come down, has been made into a 2. So a half there. We've got to include the half in the answer. So therefore we've got a half. It's the integral of a half ln x4 plus 3, 1 and 0, which is a half ln 1 to the power 4 is 1 plus 3 is 4 minus a half ln 0 to the power 4 plus 3 is 3. So it's a half ln 4 over 3. Okay. I don't know if I'm going to get away with squashing this one into this bit here. So I think I'm going to have to do B down here. Okay. Yeah, I won't be able to do that. Right, let's start. We want partial fractions. So let's spot the x squared plus x minus 12. That's going to be x plus 4, x minus 3. And we're going to say this is a over x plus 4 plus b over x minus 3. And so multiply both sides by x plus 4 times x minus 3. We get that 7 is a times x minus 3 plus b times x plus 4. If we let x is equals to 3, we've got 7, a times nothing plus b times 3 plus 4, which is 7. So b is 1. That's helpful. If we let x is minus 4, we still get 7 on that side, is a minus 4 minus 3 plus b times nothing. So we've got a times minus 7 makes plus 7, so a is minus 1. So our integral of 7 over x squared plus x minus 12 dx is now the integral, and I'll put the b one first of all, 1 over x minus 3 minus 1 over x plus 4 dx. So this is ln of x minus 3 minus ln of x plus 4. We need to put a constant of integration, which I'll write as ln c, because they're all ln, so they can all go together. So this is ln constant x minus 3 over x plus 4. Or you can just, if you don't put the c there, you can put plus c on the side. Right, I need to add a page in now, x squared cos x. So the next one, this is part C, integral of x squared cos x dx. Okay, so this is integration by parts. We've got an algebra and a trig. So the u is going to be the algebra and the v dashed is cos x. So u dashed is 2x and v is sin x. And integration by parts is the integral of u v dashed dx uv minus the integral of v u dashed dx. So this is going to be the integral. Nope, it's going to be uv. So it's x squared sin x minus the integral of v du dx. So that's 2x sin x. I'll put the 2 outside the integral sign. That's x sin x dx. So now we've got an integration by parts here. We've got algebra and trig again. So we're going to have u is x, u dashed is 1, v dashed is sin x, v cosine differentiates to minus sine, so I want minus cos there. Or you can say sine, cosine, minus cos. And we've got sine is the, so we need to integrate, integration anti-clockwise, so it's minus cos. So this is going to be x squared sin x minus 2 uv minus x cos x minus the integral of v du dx, which is 1 times minus cos x dx. So it's x squared sin x. And then minus 2 times minus x cos x is plus 2 x cos x. Now this minus can come out there and make that into a plus, but with that minus at the front there, put a minus again. So I've got minus 2 times the integral of cos x dx, the integral of cos x. Remember, anti-clockwise, it's got some of the letters of integration in it, so we go anti-clockwise. The integral of cos x is sin x, so it's x squared sin x plus 2x cos x. Cosine integrates to sine, so this is minus 2 sin x, and we put one constant of integration at the end. Now there's a quick way of doing this one. When the u is algebra and your v dashed is either trig, therefore, or exponential, u is algebra, so at the very start we had u is x squared, so it differentiates to 2x, to 2, and to 0. So the v dashed was cos x, and cos x integrates to sin x, which in turn integrates to minus cos x, which in turn integrates to minus sin x. And what you do is, the first one is as it is, the second one you've got to introduce a minus sign, the third one is as it is. So we actually end up with the integral of x squared cos x dx, x squared sin x. Look, that comes from x squared times sin x. Then it's going to be minus 2x times minus cos x, because we've got to put an extra minus in the second. Every other one gets a minus sign. So this is going to be plus 2x cos x minus 2 sin x plus c. Okay, so a student taught me that a few years ago, and I think that's pretty nippy. In fact, the reason why I put it in the exams quite a lot was to help me remember it. Because, yeah, if you're marking it 300 times, then you do start to remember these things. So that works for algebra and trig, or algebra and exponential. There's a part D to this as well. Find the area bounded by the curves y equals 3x, y equals x cubed minus 3x squared plus 3x. Oops, don't want blank. Come back. I just want a nice line one. So D, find the area bounded by the curves y equals 3x and y equals x cubed. I need to go back again. I'm in the wrong paper. This one. I will use the blank paper. 3x. Find the area bounded by the curves. Y equals 3x. Y equals x cubed. Minus 3x squared plus 3x. Okay. So we've got a cubic. And we've got a straight line. So y equals 3x. This looks something like this. Oops, no, it looks better than that. It goes through the origin there. That's y equals 3x. Next one. When x is 0, y is 0. This one factorises as, I'm just trying to do a pretty realistic diagram. X squared minus 3x plus 3. Gosh, whatever was I thinking? Right. Okay. From this diagram here, we can see. Like this is. I'm gonna go to Desmos. Let's go to y equals x cubed minus 3x squared plus 3x minus 3x squared plus 3x. That's what it looks like. Not particularly interesting. Well, it is interesting. Of course it's interesting. Let's zoom in a little bit. Yeah, not that brilliant, the graph. If I go to Desmos, that will give us a better one there. Desmos. And go and use this one here. Where's my y? Oh, there. Y equals x cubed x. Let's see where cubed is. X times x times x minus 3 times x times x plus 3x, I believe it is, yeah. I got 3 times an x. Okay. And then the other one that we need is y equals 3x. Okay. So we need to find, and it wants to find the area between the two, between the line and the curve. So it's this bit over there. I've traced that one and trace this one. So it's the area in between the line and the curve. Okay. So when I'm drawing my diagram, it looks something like this. And this is the area that we need. Okay. Right, so first of all, we need to find out where y is equals to x. We sort of know that that one's naught already, but if we didn't know that, we'd still need a method. Or we need to know where the x values, where the line equals the curve. X cubed minus 3x squared plus 3x equals 3x. That's at these 2 points here. And these are the intersections. Gosh, what's going on? At the intersections, we've got the curve, the cubic equals the line. Take 3x from each side and factorise the left. So we have x squared times x minus 3 is 0. So x equals 0, x equals 3. Let's just check that with that diagram there. Is that there? Yeah, that is a 3 there, look. Good. I like Desmos. It's good. Right, so now we want the shaded area. It's the area under the curve. So it's the area from 0 to 3 of x cubed minus 3x squared plus 3x dx. And then we've got to take away the area under Oh, I've done that the wrong way around. Oh, I'm getting tired. Must be doing too much. So we've got to do the area under the line, because that one's above. Even if you get this wrong, you'd end up with just a negative area, and then you just have to change the sign. But I'd like to get it right first time round, seeing as I've looked at the diagram and everything. So we do the area under the line. It's the integral from 0 to 3 of 3x dx, and then subtract the area under the curve, x cubed minus 3x squared plus 3x dx. So this is 3x squared from 3, 0, minus, add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, cancels out that 3, add 1 to the power, divide by the new power. 3 and 0. Okay. Now, so this one, let's do this one first of all. This is 3 times 3 squared over 2. 3 times 9 is 27 over 2, 13.5. All these, when you put the 0 in, the 0 here, they're always going to be 0 there, 0 there, 0 there, 0, and the same there. So you don't have to worry about those. And then, so this one here, 3 to the power 4 over 4 minus 3 cubed plus 3 times. The reason why I've paused a bit as well is because I just wanted to do that with that, because they're going to be the same. But I haven't done that. So I'll just carry on, pretend I haven't seen that, because you don't, things like that don't always happen. So we've just got to pretend that I haven't seen that. So this is 81 over 4 minus 27 plus 27 over 2. So it's 20.25 minus 27 plus 13.5. So then we've got to do 13.5 minus this one, minus 20.25 minus 27 plus 13.5, and now I'll cancel those. So this is actually 27 minus 20.25, which is 6.75. And that concludes question 2. Question 3. Solution of the first order differential equation given by dy by dx minus y over x is x squared, where x is greater than 0 and y equals 0 when x is 1. So this is the integrating factor method, is what we need here. The first thing to do, check the coefficient there is 1, which it is, so we can move on. Second step is to work out the integrating factor, which is the exponential of the integral. And it's the exponential of the integral of the coefficient of y here, so it's minus 1 over x dx, which is the exponential of the integral of minus ln x dx. It's the exponential of ln of x to the minus 1. Oh, look, I've integrated. I should drop that sign. Getting tired, I think. There we are. So it's x to the minus 1, which is 1 over x. So then we multiply the differential equation by 1 over x. So you get 1 over x dy by dx minus y over x squared. When you multiply y over x by 1 over x, you get y over x squared equals x squared over x. And this, and you can go straight to this step actually if you want, d by dx of y times 1 over x is, well, the original left-hand side, right-hand side, which was x squared, divided by x, which is x. I'm just having a quick check here. Yes, I've got it right. The check that I've just done in my head, this is a product rule. So if we differentiate this, second times the derivative of the first is that one there. Look, 1 over x times dy by dx. Plus first times the derivative of the second. Well, this is x to the minus 1, like we had it there. Differentiate it, minus x to the minus 2, which is there. And that's that one. So then we integrate both sides with respect to x. X squared over 2, and you need to put the constant of integration in here. And then multiply both sides by x, so y is x cubed over 3 plus c times x. And then we substitute y equals 0 when x equals 1. So 0 is a half plus c times 1. So c is minus a half. So that would make that right left hand side 0. So y equals x cubed over 2 plus minus x over 2. Yeah, you can factorise that if you wish, but I'll factorise it as a teacher. I want to do that sort of thing. X squared minus 1. Okay. And then the next one. Find the general solution of the second order differential equation given by... So it's d2y by dx squared minus 2y by dx minus 6. Remember 6y. Memorise most of that side. Equals 2e to the 2x. Okay, so solve. Okay, so we start with the complementary function, which you can imagine that as being what you have. If there's a 0 on that side, you're always going to have that going on as a solution. And this is then we find the particular integral, which is the y's. They give 2e to the 2x. So what we've got here, we start with k squared minus k minus 6 is 0. So what you do when you're finding the complementary function, that one's a k squared, that's a k, that's a constant, and you put the signs in as well. So it's k minus 3 times k plus 2 is 0. So k is 3, k is minus 2. And that tells you that the complementary function is a e to the 3x plus b e to the minus 2x. I haven't got a chance to do this now, but if you substitute this into here, you don't have to do this in an exam, so I'm not going to do it now because I don't want people to think you have to do this. But if you substitute a e to the 3x into here, you will get a 0. And if you substitute b e to the minus 2x into there, you'll also get a 0. But I'll leave you to look at that yourselves. Particular integral next. This time we look at this side here. It's 2e to the 2x. So what we actually try is y is, I call it c now, e to the 2x. And we need to work out the value of c. So y dashed is 2c e to the 2x. Y double dashed, 4c e to the 2x. And substitute these into the equation at the top here. So get 4c e to the 2x minus 2c e to the 2x minus 6c e to the 2x equals 2 e to the 2x. Now e to the 2x is never 0, so we can divide through it by 0. So 4c minus 2c minus 6c is 2. So we get 4c minus 2c is 2. C minus 6c minus 4c is 2. So c is minus a half. 2 divided by minus 4 is minus a half. So our particular integral is minus a half e to the 2x. So our full solution, y, is a e to the 3x, b e to the minus 2x, minus a half e to the 2x. Okay, that's the end. Is there anything else about that one? General solution. Yeah, this is the general solution. Right, that's the end.